See, what I want to cover here is some properties of object-oriented programming, which all of us, maybe all of you are aware about polymorphism. This duck typing is something similar to that. Sorry. And then I want to cover some part of, not all of the special methods. We have seen init method, which is one of the special methods. Now, what is polymorphism? A simple example. Suppose we have a class which is giving you whatever words we give, it gives us a code, and we are giving a name. Actually, this maybe I should have changed the thing, person and the word. The thing is, a person is making a statement, and we are calling it as, it's an example from the book, and it gives you whether the person is making a particular statement as an exclamation or a question mark. Is he the word which he is using is he ending it with a question mark, or is it with an exclamation mark? So that's why the person and word are there, and the class name is given as a quote. Now we have these two attributes, object attributes, the name of the person and the word he utters, or the words he utters, he or she utters, is given here. And there are two functions, who and says, talks about the person name and then the way he is expressing himself or herself. Now we have inherited a question quote and exclamation quote, two classes from the quote class, and then we are overriding the says method. So it's no longer going to be called specifically. If you call it with this object only, it will be called. Now if you are calling it with this exclamation object, then it's going to call this says, and then it is going to add a exclamation with the word, whereas the original one will be adding a dot with that, whereas here it is going to add a question mark. So we are differentiating our whatever methods we have in the parent class with a specific implementation based on the derived class. So this basically polymorphism is based on what object you are using it to call the method says. We are going to call different methods based on the object. So now what if I have a method which is outside the classes, is not related to any of these classes, and it is going to be passed the object which is could be just a quote object, or it could be a question quote or an exclamation quote. The object could be any one of these three. Then which is going to be called? The says function is going to be called with respect to the object. Then we know that if based on the type of the object, we are going to be picking up the says of any of these implementations, three implementation. So that is what is called a polymorphism, whereas based on the type of the object, it is going to call the method. Three different versions of says method provide different behavior of the three classes. This is a traditional polymorphism in object-oriented languages. Python, we are saying who and says methods of any objects that have them. Okay, this polymorphism behavior. I will correct this sentence. When the who says method is called, it is going with the different objects, either one of these. Then based on that, the says method is going to be called. I will show you this example anyway. That's called a duck typing. It's another name for that. Now, maybe we'll see that example, and then we'll come back to what I want to cover in methods. Now, let me take this. Okay. Now, the same, whatever I showed you there is implemented here. and the question code is the same code, and exclamation code is ending with the exclamation mark. We are overriding the says function in both the places. Now we are creating a person with a code class and quotation P1Q and exclamation code PE. So now if I call the says with respect to these objects, we are going to be invoking a specific implementation of those objects. So we will get the different behavior that is called as polymorphism. P1 says, yes, my name is name1. This P1Q question mark, this person is always questioning everything, including his own name. Is my name name1? He is kind of an emotional guy. So what? My name is name1. So this behavior is different for different objects. Okay, that this simple example of duck typing. Now let me explain this. When we call this based on different objects, it is same as what we have, but where we use normally, I'm just showing you the usage of this. Based on the object type that we pass, this function is going to call different says method. So this is actually effective or a good example of duck typing, where we don't know the type of object which is going to come in, and based on the type of the object, it is going to call the relevant method based on the implementation. Okay, based on the type of object it is receiving. So if I pass different method objects to this method, it is going to call different methods defined in those classes. So that's what is duck typing. I'm sure all of you are aware of it, but still as part of coverage, I'm including them. Now, what is special methods? What are special methods? These are magic methods. Okay, equivalent to operator overloading, we also have something in Python. In C++, we have operator overloading. Python supports special methods that allow objects to work with normal operators similar to built-in data types. Now, we know that integer and floats, we can even perform if maybe I equal to 1 and I equal to 2, I1, I2, then I1 equal to I2 we do. So this kind of objects, we compare it with each other. Here actually they are all two are objects only, so they need to have some implementation to say that how these values are equal or not. So if I do the same thing with some objects of my own object, and I want to use maybe an employee, if two employees are you want to be equalated, E1 and E2, two employees, I want to say whether they are equal. Maybe I may say that if their grade is same, okay, maybe grade 1, grade 2, grade 3, if they're both the employees belong to the same grade, then I may say that they are equivalent. Then I can do some processing based on that information. So it makes the programming easier, and the implementation specific way of comparing them can be done inside the class. So we can do two comparison of employees, or maybe two students, whatever you want. Maybe students case, we can say that if they belong to the same class, they are equal, they are in the same class, and then we can process them accordingly. So if you want to do that kind of implementation where you want to use normal operators like this, in C++ we do operator overloading, which is little more elaborate and cumbersome in terms of defining them. Here, okay, I won't say I should not be too biased towards C++. Here also we need to do similar thing, okay, to do the operator overloading. I'm not saying that Python is better than C++ in this case, but still it at least it doesn't have more definitions maybe, but they are doing it in a different way. You know, if they use a double dunder way of representing different special functions inside the class. So I want to give you that introduction to that, and I'm not going to do the details of every method, but at least a few of them which are of interest we will cover now in this section. Now the names of these methods, suppose what we want to know, suppose if I have a class, okay, and I have an employee class, and then I want to say employee object E1 is equal to E2. Here I am not specifically calling any method. Okay, I am not mentioning E1 dot something method name. So it is implicit based on the operator that we are using here. So Python has a convention that even you are trying to do this, it is a indication that we want to call a method of particular class. So that employee method, and then which method to call is what is differentiated by or identified by this method, which is a magic method with a double underscore eq and double underscore. Then it is going to call this method uh, to compare two objects of this class, belonging to this class. So you are already familiar with init, which is called after the object is created to initialize an object, right? That is, this always remember, that is called after the creation of the object, not like a constructor in C++ where it is getting created there. There are many such special methods in Python. Now, a big list of this, many of them we have already come across. The length, we call it with the list. Most of these, all of them are implemented with the built-in data types. And we are going to see how we can do this implementation for our own classes. Not all of them, but some of them. Okay, that's going to be the focus in the remaining class today at 6 p.m. Now, there is one thing which I want to differentiate between this representer REPR and then STR. Where is STR is missing here? Okay. Now these two methods, STR is also a special method, is used for, that is also given as double underscore STR double underscore. It is actually meant for, if suppose if you want to say print employee E1, I want to print the object employee E1. Now it's not a printable object, it's not like a string where you can just pass it on to the print. So it, or you have to specifically maybe E1 dot name, and maybe if name is a string, then maybe we can pass it to the print. But what if you want to print multiple information about the employees, different information like name, age, and then whatever the department the employee is part of, you want to print everything but just pass a E1 to the print. Now if that needs to be done, we need to have a str method with a special method implemented so that we can create a string. Finally, we can build a string and then pass it on to the print, which outputs all the information that we want about the particular object. So that is about str, which is for the end user perspective, whereas this is for a debugging purpose, and we can which is an unambiguous way of reading the object content or specific contents in the attributes of an object, whereas str is for mostly for user readable content. Okay, now apart from that, we will see these are all when we use less than or equal to, those kind of operators, less than, equal to, um, greater than, or whatever. And then this we will cover in the later section at 8 o'clock. Iterator, we will go into detail of iterators, and want to cover how your own object, we can make it as an iterable object, how we can iterate over, like a for in, okay, we give a list. So list and other tuple, we have this iterate, these are all iterable objects, and it implements iterator. Now you can use it with the for or a comprehension. Now what if I want to use my own objects in this and then iterate over the object, then we need to implement some special methods which are given here, part of them. Okay, we will see that in the later part of the day today. So before I, okay, this is what I want to have, but before I go into the hash, let us complete some part of it, and then we will spend a little more time in hash, then we'll end the 6 o'clock class. Now let me take special methods. Okay, now This is our one class attribute, one object attribute, and then I am implementing str. That means if I try to print my class object or the object of this class, I should what does the print do? When I say I will do this. Okay, print. I'm doing the str here. When I'm trying to convert my object into an str, a string, for that to be printed as print, it is going to for it to be printed, then it's going to call this method. When I am doing str method object, it is going to call this implementation. Okay, so then what should it return? As it promises that it is going to return a string, it should return a string built based on whatever you want to bring out about the attributes of the object. So I can put all that information, like employee information I want to put. Here I am just printing all the attribute name, class attribute value, and then the object attribute value. Maybe I will write some specific details of them. Then I will print it out. Okay, so let us see. When I do this, what did I do? I made some mistake somewhere in the code. So let me copy from here. Oh yeah, one bracket is missing. Okay, fine. Now let me clear this screen. So what happens when I do a str, when I want to convert this object, my object, into a string object, then it looks for a magic method __ str. Then it passes the object here, and then I am passing the conversion. So basically we have done a typecast here from my object type to a string type. So is equivalent to that. I get a string, and then print anyway is happy to print whatever string it gives, it is given to. So we print this. So now what happens is when you call this, I am just building this string and then passing it out. Okay, that's what is seen outside. Now let me do this now. What if I just say, instead of the string, I do this my object? Will it look for implementation of this method? Okay, so now since this class has this implementation, I get that value out. Now what if I don't have one? Okay, that I think we might have seen it earlier. So class C, sorry, maybe only init will implement it. What did I do? Def I forgot. Okay, now suppose if I say C1 equal to C, print C1, what does it do? So I want to show you, when you have not implemented a string method, a double underscore string method, a special method, and then if you're trying to print a object, it looks for that implementation here, and then it goes into the type, object type, which we know that, okay, the parent of all our classes, and it is just printing the ID maybe of that particular object. So it doesn't know what else to print. Okay, even if you have an object, a class with lots of attributes, you cannot get the print attribute out unless you have some print function, and then you print out those things. Now if I don't want that print function and you want to give a ease of use of calling your object and print the values of your object, then implement this method, which gives you your users of your class would be happy if you do this implementation and then construct a string and then pass it back, rather than asking them to remember a print method of your class and then print it out. So this is use of a particular implementation of a magic method. Now, what about REPR? It's a represent, it's a printer printing something which is maybe meant for debugging purposes, not for readability perspective, which is also either you can call it like this or even you can call it like this. There is no way of calling it like just normally like a C1, because if you want to call like this, it is going to look for only the str implementation and not the, because this is for the print is meant for the user readability purpose. Actually, that's why user is using the print. So you will not get that this function getting called. But if you want to specifically call this representation the implementation of the same, here I have not differentiated between these two, but you can put some other control characters or some other things which is meant for debugger to use, not for the readability purpose but for the internal tools to use it. Then we can use these methods meant for that usage. Okay, fine. Now I'm just saying that you can call it either specifically using this or like a typecast, what we do. Both are same. Okay, even you can use the str also the same way. You can invoke the particular implementation of the method with respect to the object. So similar to any other method that we have. And of course, you should remember to pass the self here. It expects the object name to be passed as a first parameter. Fine. Now this is done. Now one more operators we will see. Okay, we have enough time. Now I am showing you two other methods, equal to and less than. Here we are not using the operator as such, plus equal to sign or a plus operator or whatever. We are using the EQ and LT as a textual form of the same thing. Now I am constructing two objects, height h1 and h2. Now we will call these methods now. So this h1 is having a height as one attribute, and then EQ method gets two parameters. Okay, that needs to be there. Okay, even in C++ we'll say this and then this dot something, and then we have to have, it's a default. Actually there you don't mention it because it's default called with respect to the object plus operator overloading or whatever operator you are overloading, and then only we will be passing this other object with respect to it is being called, we will pass it. Here Python has made it very clear that it needs to be there specifically, not implicit parameter. So we have both of them to be there. Without that, this is not a correct way of implementing it. And this has to be an object of this type. Okay, for it to work the way we want, and it is supposed to return a Boolean value. So we are using the operator equal to here and then comparing it.